Hello everybody and welcome to this tutorial. Today I will show you how you can install aircrack and reaver. So aircrack is pretty simple. Just type in yum install aircrack -ng and it's going to pick up the right version by default, so just go ahead and press enter. In Fedora, it runs through checks every time you call yum. You can pass a -c argument in order not to do that. It says package aircrack -ng is already installed and latest version. But if you might be prompted for a question along the way. If you want to skip that, just go ahead and type in -y. That's it. With this command that I am selecting at the moment, installation will fly through. You won't be prompted for any questions, and you will have aircrack -ng installed on your system without any problems. However, reaver is quite a different story. Reaver cannot be found in Fedora's repositories, and therefore it has to be downloaded from the net. Now, there are lots of places to do this. I have chosen to download it from Google Code. That's basically the safest place from where you can download it. And let's just go ahead, open up my favorite browser, which is Firefox. You can open whatever you wish. Type in reaver Google Code. Should pop up. Yep, this is it. There we go. Now we are on Google Code website where we have reaver VPS. You have a description here, and you have a pro version here. Basically, the difference between the pro version and the one that we're getting for free is this graphical user interface, which, I mean, let's face it, if you're a pen tester, you or a white hat hacker, you're not going to be using that much of a GUI. I mean, pretty much not at all. Optimized pin sequencing, this just means that it's going to try pins in a certain order, which is more likely to succeed than the default one, according to someone, but not necessarily true. And integrated WEP cracking, and as I said, you don't really need WEP. You're not going to be able to find it these days pretty much anywhere. If you do, as I said before, those people don't deserve to have Wi-Fi. It's basically open Wi-Fi, regardless of what sort of a password you put in. Make sure you're not one of those people. I mean, fine, okay, somebody's gonna be able to connect to your network and all that, but it opens up a route for a lot worse activity, for something more malicious. Let's put it so. They'll be able to reroute your traffic and do stuff of a kind and sniff it. Not a good idea. Just switch to VPA or VPA2. Anyway. I'm going to go ahead and click on downloads in the upper left corner, and there are different versions here that can be downloaded. I mean, there are bug fixes. There are no fundamental differences in the way that reaver works in between these versions, but there are bug fixes definitely, and that is very nice. It is maintained, the package, there's support for it, and so on. So just go ahead and click on reaver 1.4.tar.gz, and it says reaver.tar.gz here, file description, etc. This is a checksum. You can use this in order to verify is your file intact, but I'm not going to do that now. I'm just going to go ahead and download it. So once it is downloaded, you can go ahead and open up the folder in which it actually exists, and I have a lot of things here. Where is it? Here we go. So it says I have different versions that I have downloaded from different sites, but if you find this package that I am selecting for you at the moment, it says reaver 1.4 FC20. The letters are pretty small, and this is maximum that I can zoom it in. Don't download it. It doesn't work that well at all. It tends to break, and the .rpm extension doesn't work quite as you would expect it to work. Just download it from Google Code and compile it from source. There's no reason why not to do it, especially when you have me showing you in detail how to do it. So just go ahead and double click on this file. You can extract it with a through a GUI method. It's far simpler. You can also extract it through the terminal, but I'm just going to go ahead and use GUI for this occasion. This is one of the advantages of Linux over Windows. By default, it will be able to unpack pretty much anything. Zip, tar, WinRAR, whatever, it's going to be able to unpack it, no problems, which is fantastic. No extra installation needed. This is all installed by default. So let's just go ahead and click on extract. Now where do I want it to extract? Let's say to desktop, because I'm going to delete it anyway, as I already do have it installed. So just go ahead and press OK. And right. No, give me desktop. Sorry for this. Okay, and yeah, I've just issued just told it to do it twice. Oh well, apply to all, overwrite. We're not gonna lose a lot of time there as the extraction process is relatively fast. Okay, so let's just go ahead, go back to our terminal, navigate over to desktop. Oops, desktop, and I imagine I have a lot of things there. Nope, it's not this one. Okay, so cd home chronic desktop, enter ls, and do I have it here? Yep, there we go. So clear, oops, clear. Let me just show you that I do in fact have it. Hello. It's much neater if I do it like this, and there we go. Reaver 1.4. Let's navigate over to that folder. Reaver 1.4, clear the screen, list the contents of the directory, go to docs first. Let's just go ahead and see what is there. And like, you might think that I am some sort of an expert or something of a kind, and that I just do these things out of my head. No. People create README files for a reason. They are there to be read because the developer has left specific instructions on how to do something. So let's just go ahead and cat it. Excellent. So the following are Reaver source files. So it has the description of what is located in each one of these files. So you have 802.11.c functions for reading, sending, and phrasing, 802.11 management frames. 802.11 is a standard, as I said before. But look at this. Look at this. The developer has actually, well, these are useless things for the time being, but the developer has actually left the entire installation process here. You have every single command that you need to run explained in detail, what it does and how you can type it in and execute it. This is wonderful, and that is why I say when you download something, when you unzip it, just go ahead and find the README file. It's there for a reason. People do tend to leave instructions there on how to do something, and they've most likely encountered the same problems that you might have encountered, so you can even see possible solutions. Anyway, you can check this inscription out, or not an inscription but the text. Reaver is only supported and only supported on Linux platforms, requires libcap, this libsql SQLite3, and one more. Can't really pronounce this. And can be built and installed by running the following commands. So execute the configuration script, make install. That's it. And it even tells you how to actually uninstall it. So they're there for a reason. Anyway, ls, of course you cannot run the configuration file from here. You need to reverse course and go to source from src. Let's see what is in there. There we go. We have configure, and you can see by default here it's executable. If I just give you a longer listing, configure, there you go. It has an X permission here, here, and here. So the user has it, the group has it as well. Anyway, type in configure. So now it's checking for stuff. It has its dependencies without which it cannot function. Type in make. Up, there we go. It's running through. So I didn't do anything out of my head here. I just went on the web. I found the safest place I can find to download the code from, and I'm compiling it here as the creator, as the developer of the code instructed me to do it. And the instructions aren't that complicated, it's just 3 commands. And the final command is make install. Now it's going to give me a lot of errors here. Well, not errors, but warnings primarily, because I already have it installed. And see here it says RM. I need to clear this out and then be able to install this, but that's not going to happen, primarily because I do have reaver installed. So let's just go ahead and check one more time if there's anything else that we've left out, if I can reach it. Down below. Yep, there we go. So no, I haven't left anything out. Basically, the last command for you will run. For me, it won't, primarily because I already have reaver installed on my system. If there are any problems, feel free to post it in the question section. I will be more than happy to help you out. Let's just go ahead and clear this out. Let's test it. Let's see. So type in reaver -- help. Excellent. It is installed, it is functional, it is responsive to our commands, and here is the syntax for reaver. This is the basic syntax. Of course, you can pass all of these arguments to it, and there are quite a lot of them. Basically, what you say is -I for network interface and -B for BSSID, or for the MAC address. Simpler put quite simply, for the MAC address, here you have it. This is just a sample MAC address that has been generically placed here, and of course we have, even for reaver, -VV for double verbose output, which is fantastic. Let's just go ahead and clear the screen. That was a way in which you could have installed Aircrack and reaver in Linux, but just in case you are a Windows user, I'll show you how to do it in Windows. Until then, I bid you farewell. Today I will show you how you can actually crack a Wi-Fi. Today we will actually get into it, now that all the prep work is done, now that we have all the tools installed and our system set up. The first thing that we will need to do is set our network wireless card into monitor mode. Type in ifconfig, press enter, and this option will display all the network interfaces that are available. My wireless interface is called VLP2S0. A bit of a strange name, I know, but Fedora has a custom for giving strange names. Like my wired connection is called P8P1, which is kind of weird, but okay, never mind. Just see which one's your is and how is it called, and adapt accordingly. Anyway, I'm going to use VLP2S0. In order for me to configure it to function in monitor mode, there are 2 ways. So the first one is what I usually use to set it in monitor mode, and the second one is what I usually use to actually check if there are any problems of whatsoever. So go ahead and type in ifconfig again, VLP2S0, which is the name of my wireless network, which is the name of my wireless network card, and type in down. Let's shut our wireless card down completely. Let's turn it off, and now we can do some modifications to it. Type in ivconfig VLP2S0 mode monitor. Again, ifconfig VLP2S0 up, and now our network card is configured to function in monitor mode. While on the other hand, while before this it was functioning in the promiscuous mode. There are several names for it, but promiscuous mode is the most common. And the difference between the 2 operating modes is that one mode and there you go, I have my wireless connection deactivated in the upper right corner. The difference between the 2 modes is that in one mode, wireless cards or general network cards are configured to accept all packages regardless whether they are meant for them or not, and in promiscuous mode they will only accept packages that are meant specifically for them. Now I'm going to go ahead and clear the screen, and I will finally start using some of the software packages that come with AirCrack. I have a list of commands here for you which we will use today on my right side, and we're going to use a few other ones, but these are the basic ones. These are the ones that you absolutely need to know. So let me just go ahead and type in airmon-ng check VLP2S0. I want to see if there are any possible processes that could cause problems, that could cause interference, and I see that there are quite a bit of them. Now, one of the first things that you need to kill is the network manager, or you should, because even though it doesn't actually directly interfere with the functioning, it does spawn some other processes that might interfere, like your active internet connection here, the DH client, especially if your network manager is configured to automatically connect to a certain network or to a wired network that you've plugged into your computer. So let's just go ahead and kill. I'm not going to take any chances today. I'm going to go ahead and kill the network manager, and then I will start killing the rest. So let's repeat the airmon-ng check. Excellent. Now I have a few more of these. Next one to kill. You do need to kill them in a certain order though, because they tend to spawn each other, and you kill a process, but you do a check once more, and you realize it's still up and running. Even though you've killed it as root, it will kill it, but it will restart it as well. Let's just go ahead and kill the DH client as well in order to prevent any interference. And the rest of killing can be done in any way you like. So let's just go ahead and kill 1556, 1556, 1215, and 1216. And 16. Excellent. Let's do a check one more time. Oops, some of them are still up. This is what I meant. It is highly annoying. So 1556. Let's see, will this work? Awahi demons are the only ones running. Apparently I have to kill the VPA supplicant first, and then I can kill these. And it can be frustrating, primarily because you can't kill them all at once. You gotta type in commands time and time again. Excellent, no such process running. There we go. Let me just go ahead and clear the screen and always perform an extra check. You see, nothing has popped, nothing should present any problems now. Let me just go ahead and clear the screen. The next thing that we want to do is perform a scan of our environment here to see what sort of connection, what sort of networks do we have, and who is connected to which network. Now, this you cannot see with Network Manager. With Network Manager, you can only see active wireless, visible wireless hotspot, visible wireless access points around you. While on the other hand, with AirCrack, with one of the tools that comes with AirCrack, you can actually see not only access points, wireless access points around you, but you can also see who is connected to them, which is a very nice feature. So let's just go ahead and type in the first command from my selected list here. It's aerodump-ng VLP2S0. VLP2S0 is our interface. So airmon-ng -ng VLP2S0. Press enter. Oh yeah, not airmon, sorry. Aerodump-ng VLP2S0. Sorry for a bit of inconvenience with my talking and writing. Never was good at that. But you can see here, these are all the wireless access points. This one is mine. It's called something. I've created it specifically for this purpose, for this tutorial. It has a good password, strong password, and we are going to be cracking it today. Keep in mind that the signal strength, you see, okay, let me just cancel the scanning process now, and I just want to explain a few things that you can see here during the scanning process itself. So the BSS ID is the MAC address of the device, which is a wireless access point. Oops, let's just move this out of the way. Excellent. So the BSSID is the MAC address of that router, of that wireless access point. The PWR is the strength of the signal. So the smaller this minus is, so let's say minus 30, minus 15 is a lot better than minus 30. Let's put it so. Minus 57, you're going to have, it's not going to be the best of connections. Minus 78 or minus 84, yeah, you might be able to connect to them, but this is not going to be a good connection at all. However, even though the signals are this weak, if you have a good enough wireless card, you will be able to perform the authentication, and therefore I will be able to render any of these networks that you see here pretty much inoperable. But that we will do in the later tutorials. For the time being, I just want to show you one of the ways in which you can actually crack the VPA2 encryption. The DOS attacks are very useful. I mean, they can practically render almost any Wi-Fi network out there useless. Nobody will be able to connect to it, or you can de-authenticate a specific client on the network, which is also extremely useful. So let's just go ahead and clear the screen. Once again, I will run the arrow dump, and I will expand this terminal so we can see some other things as well. So it says something, it's 90F6. I am looking for something to be associated with 90F6, and that is what I shall use in order to actually de-authenticate, because we are looking for a four-way handshake. It will appear in the top right corner. There we will be able to see all the packets that are coming in, and there we will be able to actually capture a file and see what is going on. But that is not possible to do at the time being, primarily because we are scanning for pretty much every single network out there, and I just wanted to show you how it looks like. The next thing that we need to do is perform a specific scan. So now we will be targeting this network here, as it has a good signal, and more importantly than that, I have a permission to do whatever I want with this network, as it is mine. These down below are not mine. Also keep in mind that we are not doing anything illegal here, anything of a kind. Everything that you see here is pretty much public information, because this is what all the Wi-Fi routers around me are broadcasting. They are broadcasting their MAC address, and they are broadcasting the name, basically. The ESSID name is not a technical term. ESSID is the term, but everybody, I don't know, refers to it as a name of a wireless access point or something of a kind. Anyway, as I said, all these are public information. This is all that Wi-Fi spots around me are broadcasting, and this sort of information you can also see on your cell phone by just using the network manager, or you can use a network manager in your computer, and you will see pretty much the same things. You will see that it's VPA2 encryption, you will see the MAC address, and you will see the ESSID. Of course, this is the ESSID will be the first thing that you see on the network. Also, you will see the channels as well. These stuff in between, you don't have to worry about those. They're not that relevant for our purpose today. Anyway, I will call the tutorial here, and in the next one we will be performing a specific scan where we will capture information and use that capture file in order to crack the encryption. Till then, I bid you farewell, and I hope to see you in the next tutorial. Today I will be talking about DOS attacks and how you can actually deny wireless access to pretty much anybody within the range of your wireless card. Now, your current range of your wireless card is not your permanent range, or probably it's not your maximum range, because you can boost the signal as well. But of that I shall speak a bit later on. For the time being, I wish to focus only on the actual DOS attack, as that can, well, not only can you deny the service, but as I stated in the previous tutorial, you are actually able to trick a user into resetting the router. Primarily because if you can't connect to your wireless, what is one of the first things that you do? You basically just reset the router. Even if you call the ISP provider, one of the first things that they will tell you is reset the router. And these sort of attacks, they don't, unless they are going over an extended period of time or something like that, they don't raise a lot of suspicion. I mean, most people, when they can't connect to wireless in their houses or something like that, oh well, reset the router. If it works out, great. If it doesn't, oh well, call the ISP. Then they try to fix it, but you're not going to be running the DOS attack probably for that long. Your idea is to force a reset. However, you can run actually permanent DOS attacks and in such a way deny service to a certain user or company or something of a kind. There is no known way to actually stop this. There are, as I've stated in previous tutorials as well, you can use some paint or that doesn't allow signals to pass through, or you can use some tinfoil or something like that on the walls, but you are effectively limiting what you can do with your own wireless in such a way, and that's not really the best of solutions. Anyway, there are certain things that a user can do on the other side to mediate this sort of an attack, such as change the channel of their wireless access point, change the MAC address, but none of those things are actually stopping the DOS attacks. All of those things, all that they are doing is simply hiding and buying for time. All you need to do is simply follow up on the changes. For example, do a scan again if you see that there is something wrong, and that's it. You will find a new MAC address, you will find a new channel, and you will see the new ESS ID as well. So anyway, without further ado, let's just go ahead and perform this sort of attack, see what happens and how can we actually confirm it. Anyway, the first thing that we need to do is set our wireless network card into monitor mode. I have a small script that I have written for myself here. I have explained it in the previous tutorials. If you're just wondering why am I not doing this via airmon-ng, so airmon-ng, and you can also do it like this, VLP2S0. Well, I've discovered that on Fedora, the distribution that I'm using at the moment, and the one that I'm using for the demonstration of this tutorial, well, it just presents problems. I mean, it creates virtual interfaces and I don't know, you get an error like name not unique on the network, and there's a way to fix that or a workaround, something like that, but I've just written my own script that I'm going to use. You can use it as well. I've shown it in the previous tutorial. All it does is bring the wireless interface down, changes its state, changes the mode to monitor mode, and then changes the state back to up again. Here we can just see it one more time quickly. Excellent. Perhaps I should have add a MAC change here as well. That would be actually a good idea, but for the time being I'm not going to do that, primarily because there is no need to hide as I am doing this to my own wireless system. However, if you're doing this outside, definitely use MAC changer-r VLP2S0. You can only change the MAC address when the interface is down. You cannot change the MAC address of the interface that is up. How to do this I have shown in the previous tutorials as well. Anyway, let's just go ahead and clear the screen. I usually run this command airmon-ng check VLP2S0. I use this not to initiate the monitor, not to set the monitor mode, but rather instead to perform a checkup to see if there are any programs, any processes out there within my computer that might cause problems or interference. Apparently there are none. If there were, once you run this command, it would give you the PIDs of the processes, and you could kill them easily. No problems there. Let's just go ahead and clear the screen, and the tool that we need to use as part of the aircrack package here is AI replay. So before we actually start doing that, we will of course need to perform a scan with a tool that we have used previously. So air dump, I have no idea why they call it, so air dump-ng VLP2S0 present, oops, aero dump. It's aero dump, sorry. I always make a mistake there, but you can just use tab as I've shown, and it's gonna work out well for you. So apparently I have some open access points here as well, and I have noticed a very strange thing. When I perform these scans during different times of day, the signal strength varies, and the amount of wireless access point also changes. I'm just going to stop this because there are too many of them now. The wireless access point, the amount of wireless access point changes, and the signal strength changes. What I've noticed that people are doing is that they actually turn their Wi-Fi's off during certain times of the day when they are not there or when they are not using it or something of a kind. And that is a very wise precaution. I mean, that's a very intelligent thing to do because if there's nobody in your house, if there's nobody using your Wi-Fi, there is literally no reason for you to leave it online. Just pull the plug. Simple as that. You increase the safety of your home network exponentially. Primarily because not only are you permanently invisible during certain periods of time, but you are also effectively limiting windows of opportunity for anybody to attack you. And that can cause a ridiculous amount of problems to an attacker. Anyway, so over here, I have my wireless interface. It's called something. It's on channel 6. And its power, it's relatively good, but look at my neighbors. I conducted this scan last night, and my own wireless was about 50 something, and my neighbors was 59, which was ridiculous. I'm guessing this guy is right next to me or right below me with an antenna attached to the ceiling or something of a kind. I have no idea, but he's getting like a really strong wireless signal. I'm gonna have to ask around to see who this is, just to see what the signal strength is on this router. But anyway, it doesn't really matter. Let's just use the AI replay. However, I didn't find a way to actually specify a channel in AI replay. Perhaps there is an option there or something of a kind, but it doesn't really matter. I didn't try too hard. What I want to show you is that you can actually change the channel of your wireless network card manually. So just type in IV. Wait, before we actually do that, let's just try a random scan and see what happens. So AI replay -ng, and here we're going to need to specify -0. So -0 is from the list of arguments that I do believe that I've showed previously, but doesn't really matter. So you see in the help menu you have deauthentication, you can use -0 instead of that. Fake authentication, you can use -1 instead of that, and so on and so forth. You don't actually need to type in the whole command, rather instead they've enumerated them, so it's a lot easier to actually use. Anyway, we're going to say -0 and space, it says count. So how many deauthentication requests do you want to send? You can specify a number. It can be a very large number here, or you can just say 1 for single deauthentication for capturing the WPA2 handshakes. Well, you're probably going to need more than 1, but doesn't really matter. I usually have a tendency to place a 0 here. 0 tells it simply do it continuously. So you can just do it until you feel satisfied or until you've achieved your purpose, and then Control-C to actually cancel it. No big deal there. Anyway, after that we need to specify a -A option, which is the BSID. And then in addition to that, we need to specify the interface that we're going to be using. Press enter, and there we go. So it says here on channel 3, but I know for a fact, and you can scroll up, you can see here something, it says channel 6. So this is not going to work. It says no such BSSID available. Please specify ESSID, so perhaps the name of the network. Yeah, that is due to this channel problem. So this is channel 3, and my wireless interface card is functioning on my wireless access point is actually functioning on channel 6, while my wireless network card is functioning on channel 3 in my laptop. What we need to do is manually configure the channel of our network card. So IW config VLP2S0, which is the name of our interface, and then channel, and then just say 6. So it's very simple. It's like English language. You have a command. So IWconfig, the name of your wireless interface. Just type in the argument that you want to change, which is channel. Same thing with mode. So just type in mod here and change it to whatever you want. But in this case, we're changing the channel. So just type in channel space, and then just type in the number of the channel you wish to tune it. You wish to change it to. Anyway, now our wireless network card is operating on channel 6, and if we repeat the command that I have previously shown, you will see immediately it actually passes. This attack is more effective when targeting a connected wireless. Yep. Okay. So there is this message that we're being displayed here. This is not an error message. This is just a note of a sort. We can also deauthenticate individual clients on the network. So we don't need to see this attack that I'm performing now. This will deauthenticate everyone on that wireless card, on that wireless access point. Everybody will be deauthenticated. I mean, you can confirm this by using your smartphone or tablet or another PC that is connected to the to your home wireless network, and it might show the status that it is still connected. But try browsing the net. Try opening up a website or something of a kind. You will not be able to do it, like not in a million years. Also, there are some MAC filtering options that routers tend to impose, but doesn't matter. I've shown you how you can change a MAC address, and you can also set a script which will rotate your MAC addresses periodically, so that can be a nightmare. Also, the routers have the option to adjust the MAC address to adjust a certain range of MAC addresses which can access it, but again, you will be able to see the authenticated clients on that network and just use their MAC addresses instead and pass through. As I said, this is ridiculously difficult to stop, and it's really painful when you're being DOSed in terms of wireless. There's very little that you can do. I honestly don't know of any known method to actually completely stop this.